Hi guys, welcome to my channel. So today's topic is water welding alloys. So some people confuse that what is welding alloys. The welding alloys nothing is that is the same as the filler metal. So but the term is the welding alloys. So we'll discuss about the what are welding alloys and what are their requirement and all these things, what are the advantages are there for the particular alloys and alloy, what is the composition of the alloys. So we'll discuss. Let's see. So what are welding alloys? So this is one of the brief explanation is here. I will explain to you. Welding alloys play an important role in fusing strong metal joint. Fusing strong metal joint. So welding alloys, what they are doing, that fusing the metal and fusing the metal and it's together comes a joint. There are many types of alloy and consideration for using them. So many types of alloys are there. So I already told that this is called also filler metals. Filler metals, welding alloys are additional metal that fill in the gap between two base metal being joined. So this is very simple. Welding alloys, the additional metal, this is the additional metal. When you are joining the two metals, how will be joined? So you need the filler metal or welding alloy is the same. We have to join together in that gap. So that is welding alloys. One definition is the metal to be added in making a welded bridge or shoulder joint. Means there is a very clear definition. Welding alloys, what they are doing, the metal to be added, the metal that welding alloys, this is the metal to be added is making a welded bridge or shoulder joint. The weld joint consists of the base metal and welding alloy. So weld joint, what are there? In weld joint, if you see two base metal are welded, so what are there inside? One is the base metal, another is the welding alloy. So filler metal can be unalloyed or pure. Combination of metal known as alloys are also commonly used. Welding alloy may contain non-metal metals such as flux, a powder material that produces a shielding gas. What they are doing? And protective slag when heated. So that shielding gas we are using to for arc stabilization or any contamination from the air. Uh, if it is added in the when you are doing welding, they be maybe the material composition of chemical composition may be changed. That will affect the material property and the mechanical and the chemical property. Several welding processes use a consumable electrode. So some welding, so many welding processes we are using the consumable electrode. So that consumable electrode, what means? That is doubles, means they are double working. One is the electrode to melt the metal, to melt the electrode, and it fill that gap of the two joint, and another is the stabilizing the arc. So this is the two work is done by together by electrode. One is the stabilizing the arc, another is the filling the weld seam. So this is the basic concept of welding alloys. Now we will discuss the welding alloys. What are there inside? What types of welding alloys are there? So if you are doing the carbon steel material, definitely the welding filler metal or welding alloys should be different. It should be same of the carbon steel alloy. So welders have many types of alloy choose from. They can differ in material, form and the property. If you see common welding alloy material, several ferrous and non-ferrous material as well as the other metal can be used as welding alloys. Aluminium welding alloys, bronze, cast-iron, cobalt, copper, magnesium, nickel, steel, titanium, and zirconium. So different consuming combination of the above metal exists welding alloys. So every welding alloy is the different material composition. Now you see welding alloy form, how it is formed. It can be maybe solid, it can be composite, it can be paste, it can be powder. It can be solid wire. If you go the solid wire, what is this? The MIG wire, the solid wire. The FCAW. It's not solid, but FCAW also solid. Sheet, foil, thermit mix, tubular wire. So all this the form you have to know the what are the welding alloy forms are there. It's maybe composite, paste, powder, solidar, sheet, foil, thermite, mix, tubular. What are the properties are there welding alloy? In the filler metal, what are the properties are there? We are using that particular welding alloy filler metal. It should be same mechanical or chemical property or higher. It should not be less. It should be same and higher properties of the base metal. So welding alloy have varying properties. Some cannot be joined with certain metals and either one bond will produce a weak joint. So two important characteristic is very important for the welding alloy properties. One is the tensile strength, another is the yield strength. Tensile strength, what they are doing? The breaking point of an alloy. Tensile strength is the breaking point of an alloy to measure tensile, how much he can tension can get absorb that energy. Yield strain, the point where stress and pressure cause an alloy to deform. These are just of two mechanical property of the metal, the measurable property that allow a metal to resist external forces without falling. So this yield strength is a make a measurable. This is one of the measurable property when how much that material resists the force without failing, that is called we need to check the yield strength. So these two important tensile strength and the yield strength for the welding alloy properties we need to check. Now you see welding alloy identification system, how you can identify the welding alloy identification system, in which code. There are so many codes or standards are there, welding alloy organization are there. One is the American Welding Society, another is American Society for Testing and Materials, American Iron and Steel Institute, National Electrical Manufacturer Association. So many manufacturers have their own system which they will include along with their W system on the packaging of their product. So if you see the welding alloy identification system, each companies have they are following the AWS or maybe STM or EISI or NEMA. So they have different requirement for particular every code. So at that basis, they are making the identification system. So basic practice how to use the properties of weld. Here are three factors to consider when selecting an alloy. Definitely, we need to know which are the factors to select an alloy. We are selecting an alloy or consumable or filler metal. That filler metal in which basis we are using. What are the factors are there? The properties of all the metal to be welded. So first factor is that the properties of all the material. The properties to be welded. So properties of the all the material means the property, there is so many properties are there, mechanical property, chemical properties, that's all property to be welded. The applicable reference specification and standard. So which reference specification and standard we are using for this one we need to know before selecting an alloy. But when selecting an alloy and the welding process, which process we are using, if you see the MIG, the different alloy or filler metal we need to use. If you see that teak, then you have to use the different alloy and different filler metal. So you got this under point also. So material property, this is a very important this subject. One mistake beginner welder often make is fusion incompatible metal. The base metal and the alloy welding alloy should have compatible properties. So definitely. The base metal have the different property and the oil alloy has the different property. But it should be compatible. Otherwise, we cannot use that particular welding alloy. We have to choose that welding alloy as per the base metal properties. Combination of metal that form brittle compound, for example, should be avoided because the finished product could be the prone or to cracking or breaking. Another factor is how easily the alloy will bond to the base metal. So it's important to think about how the finished product will be used. Will it have to endure high level or stress? If so, select stronger alloys such as combination of nickel, bronze alloy and bronze. So alloy tool, you have to use that the welding alloys. The properties should be higher than the base metal or the same. Then it will be the storage level or high level to so it can be reduced. Similarly, alloy with greater flexibility should be chosen for product that will be the bend corrosion resistance alloy. Should be chosen for those that will be exposed to water. So this is the material property. So material property, how you have to choose? You have to choose like this way. One is the base metal, another is welding welding alloys. So we have to property. We need to check it should be same or higher than the base metal. Welding standard, which welding standard and specification we are using for this? ISO welding electrode and welding consumable standard, ASME, welding electrode specification, DIN standard of welding and surface treatment, ASTM welding electrode specification, AWS welding alloy specification and clause. So these are the standards we have and the specification we have. In the particular, as per the project requirement, as per the code requirement, we have to follow that particular standard. Welding, now we have to go the welding processes. So we need to know the welding process, how it is the basic requirement. The types of welding alloy used depend on the process. So definitely welding alloy we are using depends on the process. Which process we are using that welding alloy we have to use in the different welding alloy used in the different process. So you see submerged arc welding SAW use a consumable electrode. Powder flux is fed through a hopper to seal the work. So how it is the alloy welding alloy and filler or filler metal, how it is used, how it is working? One is SAW submerged arc welding uses a consumable electrode. We have the consumable electrode we have. After that, what happened? The powder flux is fed through the same area or the outside one hopper to seal the work. So this is the SAW, the welding alloy work, how it is work. Now SMAW or stick welding employs a flux cover consumable electrode. That the electrode itself the flux is covered. Welding electrode itself the flux is covered. Then the flux melt and form into gas to seal the work. So different welding process have the different welding alloy working condition. Now gas metal arc welding, if you see the MIG welding, what happens? This process utilize a consumable wire electrode. Shielding gases are emitted to protect that. So shielding gas we are giving on the extra on the outside of the MIG welding. When we are doing the MIG welding, there is a stable arc is creating. At the same area we are giving the gases. So these are the different types of alloy, welding alloy working condition. Now flux core arc welding, as the name suggests, wire feed always with the flux core are employed for the semi and fully automatic process. So here also, wire also feed is the same hopper you can see in the flux core arc welding. One wire feed always with the flux means one wire is there and the outside in the same tube the flux is going in the at the same time when you are doing the welding. So this is the flux core arc welding with the flux core at employed for the semi and fully automatic process. Gas tungsten arc welding, also same here, the TIG welding. There is a tungsten electrode does not melt, means there is a electrode is there, does not melt, that is only for the arc creating to create the arc. And the filler metal you have to add there to melt, and it can be joined the that particular base metal to base metal. So the tungsten electrode does not melt, become part of the weld. Instead, the welder hand feeds a rod or wire into the weld pool. So that welder hand feeds a rod. We need to feed a rod or wire into the weld pool at the same time. The tungsten electrode should be there at the one area at the same area to create the arc. Now this is the welding process. You understand submerged, sealed, gas metal, flux core and the gas junction, how the welding alloy and the filler metal working. Now you see the basic given the idea for welding processes. First is stick electrode welding or shielded metal arc welding. So welding alloys are also designed for specific welding processes. So you see here the stick welded electrode welding or shielded metal arc welding. How it is working? Is a common welding process, very common. The flux covering electrode melts during the welding. This is the flux covering electrode. You see flux is here in the black area. This is the black. This is the flux. This is the core wire. This is the core wire. So when the core wire melting at the same time flux also melting. So flux when the melting and the gas is created. Here is the gas is created. In the gas created, the gas shielding, what is happening here? The gas shielding is happening. So to prevent the arc stabilization, to prevent the contamination from the any bad contamination to inside this stable arc or inside the molten pool, so it will be achieve the good quality, also stable the arc. So this is the main things you understand here, which then seal the arc and molten the weld pool. The flux also forms a slag that protects that cooling whirlpool to brace the joint and or brace the joint. So this is the flux when you are doing the gas shielding, the flux coating and the flux. What happened? There is a coating. The coating we have done from the beginning, flux coating to shield the arcs, to shield the whirlpool. So this is the solidified slag and this is the weld deposit. So we have to remove the solidified slag to get the welding quality or to get to see the weld visual. So this is the stick electrode welding or shielded metal arc welding, the principle. Now we can see here submerged arc welding SAW. So SAW, how it is happening here? You see the two roll is here, drive rolls here, two drive rolls, and one of the SAW wire is here. SAW wire, it is feeding from this particular roll. It is DC power supply, and electrode wire is here. It is the SAW submerged arc welding wire, and covering flux. At the same time, there is a hopper, and the hopper is there, and they given the fused covering flux that area. Okay, fuse covering flux in that particular area from the hopper, and it is and that time it is stabilize the arc and molten pool. So this is the weld pool, this is the submerged arc, and this is the flux. After flux continuous it going, then it is the flux will be generated and you can be remove the flux when it will be finished the welding. So this is the different types of this. The at the same time, the flux is the hopper is there. You have to fuse covering flux. You have to put here from the hopper. So this is you see here. Use a powder flux processes. Use a powder flux to shield and isolate the arc weld pool. The powder flux is fed via a hopper, while the consumable welding electrode creates an arc that is covered by the powder flux. So this is your the electrode wire, and this is covering flux from the hopper to stable the arc and create the molten pool. Now you see the flux core arc welding FCAW. You can see this is the core wire, and flux is there also inside the at the same wire. It is the flux and the electrode, the base metal. Now you can see here gas field created by compound arc and metal transfer. Now processes primarily sealed the weld pool via a slag that forms during the decomposition and vaporization of the electrode flux core. So this is the flux core. Also flux is there in the electrode. So when it is melted, the weld pool also created, and the flux is solidified slag is happening here, and molten slag is here. So after finish the welding, you have to remove that slag. So this is the happening in the FCW welding. So FCW alloys are wire feed alloys with a flux core used. So this is the wire feed alloys. Wire is there, but it is flux core, and it may be automatic or it may be semi-automatic welding process. So this is for FCAW welding. Now we can go for gas metal arc welding, GMAW welding. So GMAW welding, how it is happen? This is metal inert gas welding. So means we have a wire to feed the workpiece and create the arc. At the same time, we have to feed the gas at the welding joint. To for what? Because inert gas to use for to stabilization the arc, to stabilization the molten pool. So this is the things, that's why metal inert gas welding process use a gaseous mixture opposed to a flux to shield the weld. So definitely every that welding alloys we are using to shield the weld first, and to any contamination should not be created in that welding. That's why that we are using the flux. The flux is one thing. Another is the solid wire for the metal composition we need for the to create the to get the good mechanical property. You can see here the GMW plus GMW 0.06 is the material thickness. Gas, which gas is required? Argon. It is the gas blend, and the second one is the GMW plus GMW. Material thickness is 0.05250, 0.2502, 0.500. It is argon helium. So this is a very important chart. So you have to check. And the GTAW, this is called the TIG welding. We can use the tungsten inert gas welding. This is very interesting for this, those are new, those are understand. Now you can see here, this is one of the non-consumable electrode. This is non-consumable electrode, and this is, we have to see, this is the electrode holder is there, and the welder is holding that electrode into that at the workpiece, at the joint area. At the same time, you see the filler rod is there feeding that, feeding here. So filler rod is melted, and it goes to the here, the welding metal, the molten pool is here, and the weld is created. At the same time, what that consumable tungsten electrode happen, this arc is creating here. To create the arc, it needs the non-consumable tungsten electrode. It will not be consumable, and that nozzle is here. So this is the filler rod. Okay, and this is the gas is going here, shielding gas. This is the shielding gas. You can see the blue color is going the shielding gas. So these are all, this is the one of the process for TIG, tungsten inert gas welding. And after that shielding gas is feeding here, then it's the molten pool, weld pool is here, this is the arc. And to stabilization the arc, we have the use the shielding gas. So this is the gas tungsten arc welding. So I think this is the this welding alloys from the beginning. This is the, what are these welding alloys or filler metal, and what are the common alloy material what are using for particular base metal. So all people I think understand for each pages, for particular which welding process, how you are using the welding alloys or filler metal, and how you are shielding the arc, or shielding the weld pool. So this is very clear for this basic understanding for this all process of the welding. Anyway, thanks for watching my video. Don't forget to share and subscribe my channel to get regular video. If you have, I'm getting good views, and if you have any comments, please send me in comment box, and I think I will get reply as soon as possible. Thanks a lot again.